Hello, everyone, and welcome back. This is going to be part two of the lesson five, module six. We're just going to kind of continue and work through the problem set, just part by part and kind of break it down. This is just a continuation, like literally a continuation from what we did on Monday. So go ahead and grab your materials if you don't already have them, a green workbook, a notebook, or a loose piece of paper, pencil, grid paper. I'm excited because I love the coordinate plane. I feel a lot like SpongeBob. And if you haven't already guessed, SpongeBob is my favorite cartoon character and cartoon show, honestly. Um, and that was fun facts with Miss Satchell. Okay, so let's go ahead and get to it. Um, I would like to say I have included another blank copy of the grid for this lesson, just so that you can screenshot it and work on it if that makes it a little bit easier for you. We're going straight into the problem set. Now, the most important part about using the coordinate plane and following these kind of instructions is that we actually read exactly what they're asking us to do and do exactly what they're asking us to do. Um, I mean, it's pretty straightforward. And there's only sometimes when they try to trick you, but for the most part, they just give you right, straight instructions. Okay? So they're asking us to use the coordinate plane to the right to answer the following questions. So we're using this coordinate plane. The only difference between this one and the one on your on the blank copy is just this one has point A and B already there for us. But if you can identify point A and B already, you could just draw that on your little grid. All right. So it says use a straight edge to construct a line that goes through points A and B and label the line E. You don't necessarily need a straight edge, but just connect A and B using a line. Pretty simple, pretty easy. The name of this line is E. I didn't label it because I didn't want to put too many figures and stuff on this graph, on this grid. I just wanted to keep it kind of simple, but it's important for us to know that this line is named E. So when they say line E, they're talking about this line. And this is going to help us kind of understand when we get further along and there's more than just one line on a grid, on a plane. So it's just good practice for right now. All right, so B says line E is parallel to the blank axis and is perpendicular to the blank axis. This kind of reminds us of what we talked about on Monday in the first part of the lesson. When we talked about what axis is parallel, what axis is perpendicular, what does parallel and perpendicular mean. If you kind of need to go back to your notes, or if you watched this video first and didn't watch the other video and you're kind of confused about what I'm talking about, maybe it's the time to go back to the other video and then come back here. That way you are with me and we're all on the same wavelength. Okay, so I'm going to give you some time to try to figure this out. If you already knew it off the top of your head, that's fantastic. But some people don't have that. They need to pause and figure it out. But if you have said that line E is parallel to the x-axis and is perpendicular to the y-axis, you are correct. Remember, parallel means that two lines, they are a pair of lines that never cross, they never connect, they don't touch at all. And perpendicular lines are lines that cross and create 490-degree angles. All right, so now it's asking us to plot two more points on line E, this line, name them C and D. Okay, so I'm gonna put just 2 points on this line. Um, one's a little off, but we can guess where it's supposed to be. Um, so now that we have this, I just put C and D wherever. You can put your own C and D wherever you would like it. You don't have to put them exactly where mine is, but they do need to be on this line. It needs to be anywhere between A and B. So as long as they're in between A and B, and there's two of them, and you name them C and D, then have at it. So now part D asks us to give the coordinates of each point below. So now we're going to look at A, and when we're finding the point of the coordinate, we look at the x-axis first. So this one isn't fully labeled. We kind of generalize where it's supposed to be. If this is 5, that means this is 4, 3, 2, and 1. And the same thing up here. 1, 2, 3, 4, and 5. So if we look at A, we're going to go down to the x-axis first. And that's going to give us to 3. x3 and y4. x3 and y4. So that is what our coordinate for A should look like. All right, and on your own, go ahead and do B. You're going to find where the x-axis is first, because we write the x-axis first, and x comes before y. And then we're going to go across to the y-axis to figure out which one it is. You can also kind of guess. You can make an an educated guess on what the y-coordinate could be or the x-coordinate could be based off of just A. But if you have 11, 4, you are correct. Now, even though our C's and D's are different, I want you to pay attention to these two coordinates. We can see that our y coordinate is the same. Our y coordinate is the same, and it kind of we're in the same area. And if these 2 points are in between them, what can we kind of like assume? What do we already know about C and D based off of this, knowing this y coordinate and this y coordinate, and knowing that they're all connected, and also going off of what we talked about on the lesson before? What can we assume about C and D? I want you to write your answer to that question in the comments below. What can we assume? What do we know about C and D based off of everything that we talked about? All right, and E, what do all the points on line E have in common? That's kind of the same. It's a similar question, or a similar answer to the question I just asked. But what do you think? What do they all have in common? That's another question. So you're going to answer 2 questions in your comments. What can we assume about C and D based off of what we know? And then 2, what do all the points of line E have in common? Okay. And for F, it says give the coordinates of another point that will fall on line E with an x coordinate greater than 15. So pause the video if you haven't already answered the question. Answer the question in the comments and then come back, because then we're going to talk about F. So F, it says give the coordinates of another point that would fall on line E with an x coordinate greater than 15. So if we extended this x-axis to like 16 or extended it to 20, what could be a point? What could still be a point? If we extended this line and these lines are parallel, that means we would extend this line as well. What we should notice, and what you should have said, is that all the y coordinates are going to be the same. So regardless of how long we keep this line going on, we could extend it to like 50 or 1,000 or 100 or a bajillion or a gazillion. But regardless, it's still, our y coordinate is still going to be 4, because this line will go on and on forever. So to kind of answer E, what do all the points of line E have in common? They're going to have the same y coordinate. So if we were to give a coordinate for another point that would fall on line E with an x coordinate greater than 15, that just means we could put 16 for, or 17 for, or 100 for, or 75,000 for. Regardless, our y coordinate is going to be the same, because it's going to be on the same line. Okay? Now, before we go into the exit ticket, this is kind of like your extra if you really need more practice with it without my voice kind of guiding you. If you just need your own practice with it, just to work with it a little bit more. This one is a little bit different because they have half marks. And there's going to be a point where they bring in fourths. If you want to challenge yourself a little bit, if you want to work on it, if you think that like, oh, Miss Satchell, everything you're saying is so easy, you are just like dragging me along, ma'am. This is a little bit more of a challenge. So if you're up for a challenge, you can go ahead and do this as more practice, and turn it in, and let's see where you are. That's the only thing I'm gonna give you. Boom. That's the hint. Moving on. All right, to our exit ticket. Now, it's the exact same thing. Say it with me. The exact same thing that we did when we went over the first part of the problem set. Okay? You're just following the instructions. You're following the instructions. You're making a line, one line. I know that some people that turn in their work and they have more than one line. You're only using one line when we're talking about this. Keeping it simple. One line that connects A and B. Okay, you're going to answer what axis is parallel to line L, which is going to be the line you create when you make the line. And then what axis is perpendicular. You're going to plot 2 more points on line L, name them C and D. When I tell you this is exactly the same, I'm not even kidding. This is the exact same thing that we just did. So if you follow along with me, and you're right with me, and this should be a breeze. Okay, and 4, give the coordinates of each point below. Now, depending on where you put C and D, I can already assume that out of all of these points, there's going to be at least one coordinate that's going to be the same for all of them. But C and D is going to look a little bit different from person to person because you're just going to point them wherever. But A and B are going to be the same. All right, and last, give the coordinates of another point that falls on line L with a y coordinate greater than 20. So if we extended this to like 25, what could another y coordinate? If we extended both of these, the y axis and the x axis to like 25, what could be a number or a point that falls in between that line? Okay. Cool. Well, thank you once again for joining me and have a great rest of your week. I look forward to seeing all of your answers. Bye.